All right, so now we've started recording. We are live. So welcome again, guys. Welcome to this session on number properties. It's going to be a very, very interesting session, especially if you like quant and you've struggled with number properties before, especially if remainders has not been something that you're very comfortable with. This session will change all that. So in this particular session, we're going to focus on majorly divisibility and remainders, and we're going to learn a lot of new things along the way. So before we get into that, in order to help you out with today's session, we had sent a couple of video lessons your way, so you can see it here in the warm-up section. If you guys have gone through this, it would be great. That if you've already gone through this will set you up for what we're going to discuss today. But even otherwise, there's no problem. Even after you go through the session, log in with your free trial account. These videos are there for you to consume. These videos are there for you to learn from. So make sure you do that at the end of the session, once you're done with the session, if you've not already gone through it. Let me also talk about upcoming webinars. So at e-GMAT, we keep doing this week on week. We're doing a lot of free seminars for you. Next week, we have on Saturday, that's May the 1st, we have a free GMAT RC webinar. This webinar is for those people who really, really struggle with reading comprehension. It's for those of you who do not enjoy reading comprehension. Some of you may be voracious readers and really love reading a passage, but then there's so many of you who do not have that reading habit already inculcated. If you're one of those people, you would really love what we have in this GMAT RC webinar. It's all about reading strategies that you can apply even if you're not a voracious reader. And the very next day on Sunday, we have a free GMAT quant workshop. The beauty of this is like a proctored test. It's a simulation of how the test would be for you. And based on how you perform, you get personalized insights on what you should do, where you faltered, and the way forward. So very, very interesting sessions lined out next week for you, for those of you who are interested in this. So with that said, let's get to know you guys a little better. So there's one poll that we had already put in, that's when do you plan to take the GMAT? I would also like to know about your target quant score. So for some of you, the target quant score could be 51. You'd not be happy with anything other than 51, but for some of you, it may not be as much. And another question I have for you is, based on your estimates, your current estimation, what's your current quant score? Where do you stand currently and where do you wish to go? So this is where we get an idea about the level of the class and the interest and inclinations of the class. So I see around 100 of you here. So let's make sure you are participative. Let me open this poll as well. What's your current GMAT score? All right, that makes a lot more sense. All right, let's look at the first piece of data. When do you plan to take the GMAT? Oh, it's like half the batch, pretty much half the batch has not picked a date yet. So it might be the case that some of you have not started your quant preparation journeys, may not be familiar with number properties concepts. If you're not familiar with number properties concept, this session will be fantastic for you. You learn some stuff that you'll be able to apply in a scaled fashion for any level of difficulty. So that will be fun. I also see a small chunk of you who are going to take around 20% of you who have the GMAT in your immediate horizon within the next 30 days. For you guys, by now you probably know the concepts well. So some of the warm-up questions that we have might be on the easier side, but it would, if your concepts are not clear somewhere, it will come out in a session like this and you would still be able to refine your approach somewhat. So it will be a good session for you guys as well. Looking at the second piece of data, target quant score. Oh, I'm very happy to see around 78 or 80% of you are targeting that 50, 50, 50 and 51. And that's pretty much another 90% if you take 49. So very good. I'm very ambitious group of students here. I like to see that. You should all have a lot of ambition. Then comes, what's your current score? So yeah, a good chunk of you, around 60% of you in that 40 to 42 range. That's fair. So hopefully, at least as far as number properties and remainders are concerned, by the end of the session, I want you guys going out of the session feeling very, very confident about number properties. Very good. With that, let's kind of move to the main presentation pane. Let me clear this out. And just give me a second while I set this up from my side. All right, so you guys should be able to see the first slide. That's number properties quant live session. If you're able to see the first slide, click on yes. Just because sometimes the internet takes time for some people. All right, so this is visible. Fantastic. Let me take this away. So some sanity checks, guys, things that we normally expect. As we run through the session, if there's something that's not clear, if you have a question that you want to get asked, make sure you put it in the Q&A pod. That's right here, the one I'm shaking right now. Ashutosh is here. He can support us. He can help you out with those queries if something is not clear. All right. Apart from that, I'll periodically keep bringing polls for you guys to answer. I'll sometimes ask you whether you guys understood something is yes or no. Make sure you participate. That way, the group as a whole does much better. So let's get into the core discussion. Yeah, 2 parts to the webinar today. So we are gonna get straight to the core, and after that, if you have any questions, we could take that. Usually, the session is presented by either Atreya or Shweta, but especially in India, we're facing a pandemic, so it's a tough time for a lot of people. So I'm taking it on his behalf. So also be kind. I'm taking this session for the first time, so let's see how that goes. But I'll make sure you have a very good experience out of it. So the core agenda of today's session is to solve every NP question using a unified approach. What do I mean by that? The idea is not to give you a horses for courses approach. The idea is not to introduce a different logical framework for each question. That doesn't scale. That's not an approach that scales. The idea is to identify one method, one process that works for all kinds of remainder, divisibility, and remainder questions, irrespective of difficulty level. The tough questions, the easy questions, it doesn't matter. The method should work. The process should work. That's kind of one of our core objectives of today. So as far as the purpose of the session goes, yes, we are going to look at remainders, divisibility and remainders at a very, very specific level as far as concept is concerned. But it's not just that. By the end of the session, one of the key takeaways that I want you guys to have is when it comes to GMAT quant, it's not just about knowing math. Yes, we all need to know the mathematical principles. Yes, absolutely. There's no solving quant if you don't have the core math principles. Or in other words, you do need a sound understanding of the basics. But that's about it. It's just a sound understanding of the basics. You don't need expert level mathematics. You need a sound understanding of the mathematical principles. That's it. But more than the math, what you need is an application of logic. GMAT overall across the board, whether it is SC, CR, or whether it is quant, is more of test of logical ability than it is of anything else. It's your ability to apply logic that matters. So even in a math question, what you would see that is that yes, you need to know some math fundamentals, but beyond that, you need to be able to apply logic coherently. And to do that, what you need is a structured approach, or what we call as a proper process. And that's something that I want to impress upon you right at this point. And by the end of the session, you'll appreciate this a lot more. It's not just about the math, it's about the process, following a systematic method so that you don't miss out on any pieces of logic that you should. So keep that in mind, logic over math. Let's talk about how we are going to go about today's session, the progression of the session. And this is where the structure is very, very interesting. We are not going to start at some very easy questions. First, you're going to solve 3 questions, which are data sufficiency questions, which are 700 level plus questions. At least they consider 700 level plus questions. We are not going to discuss this at this point of time. We are going to come back to this. So you're going to solve some really tough questions, which are considered tough. Then we're going to go through some fundamentals from the very easiest level. So less than 650 level, we're going to build some fundamentals. All the concepts that you either already know and may have forgotten because it's been a long time, or you really, really still remember. We're going to go through all those fundamentals with an increasing layer of difficulty. We're going to start with 5 warm-up questions, which is less than 650 level. Then we move on to 650 to 700 level questions. And then we move on to 700 plus level problem solving questions before we come back to the questions that we began with. By the time you reach this point, you should be able to do much better with these questions. And that's something we're going to look at a group level as well. We're going to see the accuracy at this point of time, and we're going to see the accuracy at this point of time. And we're going to compare and contrast. Did the group really learn? So it's going to be very, very interesting. So in total, that's quite a few questions that we're covering today. So are we ready to solve these questions? Let me just bring in a short answer part. I just want to see a yes or no. Just give me one sec. All right. So before we start, on a very auspicious note, can we have a lot of yeses for all of you who are participating? Math is fun, guys. We should have a lot of fun with the session. So perfect. So before I jump into the first question, again, a little bit of the expectation setting. When you see an option choice, this is the poll that you would have to fill. So if the question has only 3 options, you'll only have 3 options. You see this option called still solving. Make sure you fill that. All of you who are going to solve this question, please click on still solving. That way, I'm not going to time you. You guys are going to time yourself. When a significant number of you have actually solved the question, only then will I move on. Because I don't want to put time pressure on you unnecessarily at this point. So click on still solving. Right now, there are 150 participants in this webinar. When this number increases a little more, let's get that to around 80 and then I'll share the question. All right, so here's your first question. All the best. Just one sec, guys. Let me bring in the right poll for you. This should be Q8. My apologies for that. Yeah, here it is. Same logic, guys. All those who are solving, please click on still solving before you begin. Start getting your answers in, guys. I see that most of the class is done. Let's take another 10-15 seconds. Alright, guys, last 5 seconds. 3, 2, 1. And let me end the poll. Let me also broadcast the results at this point. I want all of you guys to make sure you remember which answer you chose, because we are going to revisit these questions again towards the end of the session. So don't forget which answer you chose. So this is how you guys polled. Let me take this out. Let me bring the next question. That's question 9. We're calling it question 9 because we're going to come back to it after 7 questions. Same principle, fellows. Let's click on still solving, all of us. All right, now I'm gonna share the question. Here you go. Good luck. Let's start bringing those answers in, folks. All right, let's take another 10 seconds. Most of you are done at this point. Five, four, three, two, one. All right, I'm going to end this poll. And again, let me ensure that the results are broadcasted. You should be able to see them now. Let me just check if the results are. Yeah, you should be able to see the results. So as always, make sure you note down which answer you chose, and you can also look at how the actions chosen by the group. So let me hide this. Time for the last in this series, that's question number 10. Same approach, guys. Start with still solving so that you guys can time yourself. And here's question 10. All the best. At this point, around 50% of you are done. So this question is taking a little more time. I'll Alright guys, almost time to wrap up. Another 15 seconds. Alright, 5, 4, 3, 2, 1. Any of you still solving cases want to take a last shot? This is the time. And I'm gonna pause this now. Alright, so let me broadcast results. Again, take a note of how you performed. I mean, rather, which answers you chose and what the group has done. Alright, so let me get this out of the way. We are not gonna discuss these questions for a while. Let's hear from you guys. How did you feel about these questions? Comments. Who found it easy? Who found it difficult? Who found it not too difficult? Difficult, not confident, hard, very difficult, interesting. Yes, I like to see that as well. Last one was difficult. Definitely, I agree with you. When I solved these questions, I felt the same way. The last one is a little more, a tad bit more difficult than the other ones. You're right. Medium in terms of e-GMAT. Okay, that's interesting. All right. So I can see that quite a few of you have, felt the difficulty in these questions. And these are essentially, these are the questions at the higher end of the spectrum. These are 700 level. These are considered to be 700 level questions. So what we are going to do right now is, let me just clear this. All right. What we're going to do right now, as I said, is forget about these questions. We are only going to come back to them once we have learned some concepts. Or if in the case that your concepts are a little rusty, remember those concepts. That's also there. Some of you already know all this stuff, but it's just that it's been so long and you've forgotten. So in this warm-up section, you're going to take a look at some very, very basic questions. 5 questions which are very basic. Typically, you should not have too much difficulty with it. We're not going to get too much into the detail because you guys would understand this immediately. Right? But it's about testing and ensuring that we are all on the same page as far as the concepts are concerned. That's the only thing that matters here in this stage. So let's talk about question number 1. Here you guys can go directly for the correct answer. I don't mind that even if you don't go for still solving. So 3 options for you. Choose the correct answer. All right, let's take another 10 odd seconds. 80% of the batch is done. Three, two, one. And any of you guys still solving, want to take a final shot? Take a shot. Be bold. This is a low risk environment. So I'm giving another 2 seconds and let's hold. So let me broadcast the results. We're going to discuss this straight away. Option B is the correct answer, and around 70% of the batch have chosen this. But that means there's this 18% of you who have not chosen this, who went for option A and option C. And that's where the first piece of learning is. The question is about divisibility by 3, isn't it? It's concerned with, is Z maybe divisible by 3? Is it always divisible by 3, or is it not divisible by 3? So on the short answer pod, who can tell me what is the rule for divisibility rule of 3? When would a number be divisible by 3? At this point, it's more like revision. Sum of digits, absolutely. If the sum of digits is divisible by 3, then yes, that particular number would be divisible by 3. And that's all you need to solve this problem. And that's why 70% of the batch did get the correct answer. So the problem would have come for those 18% of students who did not get the correct answer. You might have taken a few examples. You might try to see a few examples, and you're kind of confused whether is it always the case or could there be some other case. The correct way of going about this would probably be, let's take an example of consecutive numbers. X plus 1, x plus 2 is an example. You could also take x minus 1, x and x plus 1. That's also 3 consecutive numbers. And see what happens when you sum it up. When you sum it up, you get 3x plus 3, right? Or in other words, 3 into something. 3 into some a or b, whatever it is. Or in other words, that sum of digits is always divisible by 3. Is this clear? Let me just give that to a yes, no. For everybody, is this clear? Especially those who went wrong, who went for maybe. Do you see why it's not maybe, why it's always? It's always a function of 3. It's always divisible by 3. Perfect. So that's one concept that we have resolved. Now let's go to the next question. And we're going to use the same question. Just give me 1 sec. You guys can start solving this. Meanwhile, let me clear all answers and broadcast results. Here you go. Let's start with Alright guys, let's take another 10 seconds. Three, 2, 1, and let me end this. Alright, so let me broadcast the results, and you already see something interesting happening here. 50% of you chose choice A, which by the way is the correct answer, but around 40% of the batch went for choice C, and another 8% went for choice B, which is it's always divisible by 4. Again, this particular question is about divisibility by 4. So on that short answer pod, what is the condition? What is the rule for divisibility by 4? When would you say that a number is divisible by 4? Not sum of last digit. Yeah, the rest of you have got this. When you say last 2 digit, the more precise way of saying that would be the number formed by the last 2 digits. It's not like if you're looking at a number like 56, it's not like 5 and 6 are individually divisible by 4. The number formed by the last 2 digits, that's 56, is divisible by 4. If that number that's formed by the combination of the last 2 digits is divisible by 4, then this number is divisible by 4. Perfect. In this case, there's a very, very important learning here. You're talking about the last 2 digits. You don't care about the rest of the digits. If you start taking use cases, you can easily figure it out. So if you think about 2, 3, 4, 5, it is a 4-digit number whose digits are consecutive numbers, but Firstly, it's an odd number. It's not even an even number. If it's an odd number, can it be divisible by 4? Yes, no. Let me clear all answers here. No, right? It cannot be divisible by 4, which means you already have a use case that negates option B. You cannot say that Z is always divisible by 4. Now let's look at another possibility. What about 3, 4, 5, 6? If you look at 3, 4, 5, 6, 56 is divisible by 4, right? 14 times 4. So definitely there are cases, what this will tell you is there are cases where Z is divisible by 4. So at this point, I'm okay with option A, which says Z may be divisible by 4. But is that all? What about 1, 2, 3, 4? It's not divisible by 4, right? It's an even number and it's not divisible by 4. Algebraically, you could do it, but it would be a very, very big waste of time if you do it algebraically. So, I mean, you take a lot more time if you do this algebraically. Here, the key learning for me is what a key process skill which we call as consider all cases. It's good to it's very often it's very simple if you can consider cases, but the caveat, what you need to be careful of is you need to be sure that you're considering all the cases. So this is one of the fundamental process skills that we talk about. And in fact, let me bring this here. So here is a link. That first link there is all about process skills. So consider all cases is a very specific type of process skill. Applying constraints is a process skill. Visualizing is a process skill. So we actually have an entire YouTube series dedicated to these skills. These are the subtle things that you should be doing when you're solving questions. You miss out on a particular constraint, it's very easy to fall for a trap. That's when some logical piece was missed by you. Similarly, if you fail to consider all cases, you may end up choosing the wrong answer. So you can see why option C is also not the right answer. It's 34% of you chose option C, which says Z is not divisible by 4, but it can be divisible by 4 too. You cannot say that with any certainty. So what does that tell you? How are you guys feeling about this? Do try this process skills link. I think it's very useful for you when you get the time. Good. Let's go to question number 3. We are going to use the same poll. I'm just going to clear all answers, remove broadcast results. So you guys can click on still solving, and let me move over to the next question. This is question 3. It's a very interesting question. Let's have fun with it. Let's take this out. Thanks for pointing that out. Here's your poll. Oh, thanks for pointing that out. I didn't realize we had gone to the poll for 4 questions. My apologies for that. Let me bring the right poll. There you go. There you go. And it's opened. Perfect. Alright guys, take another 5 seconds. Most of you are done already. Three, two, one. Perfect. So let me end the poll and broadcast results. Fantastic. Now we are seeing very good results now. 90% of the batch got the correct answer, which is 896, that's option C. Uh, One of you was asking on the short answer part, can you explain it algebraically? Honestly, the divisibility rule by 4, you should know it. If you get into the algebra of it, it's going to derail the whole discussion. So I'm not going to get into that right now, but feel free to work on it. But divisibility rule of 3, you should know. Divisibility rule of 4, you should definitely know. Last two digits should be divisible. The number formed by the last two digits should be divisible by 4. Like an axiom, you need to keep that in mind. For if you are mathematically inclined, feel free to get into the derivation of it as well. I encourage that. All right. So how was this question, guys? Easy, right? So the concept is also fairly easy. It's not very difficult. The divisibility rule of 8 is also fairly well known. The last three digits, the number formed by the last three digits should be divisible by 8. So all you had to do was divide 897 by 8 and see what you got. If it was divisible, you would have got remainder as 0. But because it's not divisible, you got a particular remainder. And that remainder here was 1. Because 896 was actually divisible. So then the only thing you had to figure out was, should you add this 1 or should you subtract this 1? So after dividing 897 by 8, something still remained. That's what the fundamental definition of a remainder is. Which means if you had taken out that 1, it would have been perfectly divisible. So those small number of you who fell for option B, instead of subtracting this 1, you might have added this 1 to 897. Make sure that that's a silly mistake. You really should not be falling for it. All right, because these are very basic questions. Ravish, what you point out is, of course, that's also true. You could also go that way. But we are slowly getting into the remainder piece at this point. With starting with divisibility, now we are getting into reminders. So let's get ready for the next question. So this one also has 4 options. So let me remove broadcast results and clear all answers. And there you go. All the best, guys. All right, most of you are done. Take another 10 seconds and let's start discussing this. Four, three, two, one, and let's end this poll. Let me broadcast results. So not as great an accuracy as last time, but still we are doing well. Around 73% of you have chosen option D. Option D is the correct answer for this question, but quite a few of you have fallen for A, B, and C. So this is something that we're going to discuss in detail, and it is in this question that we're kind of going to get into the core of the session, the core concept that I want you to take away from this session in terms of the actual math. This particular equation is very, very important. So there are multiple names by which this equation goes around. Some people call it the divisor and remainder equation. Some people call it the Euclidean remainder theorem. You guys have all seen it, but from here on, all the questions that we are going to solve, we are going to use this equation in some way or the other. It's the fundamental. In fact, if you guys are not familiar with this, write it down because we're going to use this repeatedly. It's very, very important. So what exactly is this equation? Dividend is basically what is being divided. Here, the number n, for example, is being divided by 204. So my dividend here is n. What is a divisor? What is it being divided by? What is it? What is that number that is doing the division? In this case, it is 204. That doesn't come well on the surface, but we're talking about 204. Quotient, the quotient is unknown. We can just put a variable for this. You could put this as x or q or p, it does not matter. And remainder is what remains. So again, I'll give a very, very quick example of, just for anybody who is not familiar with how to write in this particular format. Most of you are familiar with this, but in case there is somebody here for whom this thing is new, let me just quickly give a quick example here. Let's say you want to write 75 divided by 10. You want to translate this information into this equation in this format. If you're dividing 75 by 10, you should be able to figure out that 75 is, the divisor is 10, 75 is the number, the divisor is 10, the quotient in this case is what? 7. And what is the remainder? 5. Any number you see, you should be able to do this. X divided by y, you should be able to write it in this format. Everybody with me so far? Kush, at this point of time, we are still in the warm-up phase. All these questions are lesser than 650 level. We are getting to it. So yeah, on the short answer part, especially for anybody for whom this is new, do you guys see this representation? Anytime you see a number being divided by any other number, you should be able to arrive at this. For me, this bracket quotient, as far as reminders go, this particular quotient piece does not matter as much, but the remainder matters. This 5 matters a lot. The divisor 10 matters a lot. Everybody with me? Let's put a yes on that short answer. Yes. I'm pretty sure all of you, or at least most of you, are familiar with this, but this is still the crux of what we're going to do today. So it is very, very important to figure out, because we're going to use this to solve all our questions. Okay. So let's look at the question here. If a number n leaves a remainder 3 when divided by 204, what is the remainder when n is divided by 4? So what we are being asked is, if this n was divided by 4, what would you get as remainder? If you had to translate that based on our equation, it should look like this, right? In this equation, what you need to find out is r. Very, very simple. We need to find this r. Now, there is also a constraint. I told you about process skills. One of the things is you always have to remember the constraints. R always has to be less than 4, right? Similar to that example, when you said 75 is 7 into 10 plus 5, you will notice that 5 is always less than that 7. All right. So there is a constraint. The constraint is r is greater than or equal to 0. If it is equal to 0, that means that number is divisible, perfectly divisible. Otherwise, it's greater than 0. And it will always be lesser than 4. It will always be lesser than the divisor. So make sure you remember that. That's a constraint. You always have to keep in mind as far as reminders are concerned. So this is what you need to find. And what are you given if you translate this information from English to math? What would you do? N equal to 204 some quotient plus 3. Again, the quotient really doesn't matter. What matters is the divisor and the remainder. Now, look at the structures. They're very, very similar. If you can express this to look like this, if you can express 204q plus 3 as some 4p plus r, then whatever you have as r is the correct answer. Correct? It's as simple as that. So in all these questions, the approach that we really want to build upon is, what do I do to represent this to look like this? So if you look at 204q, I want to bring it down, crystallize it to a format where it's some 4x for 4p or 4q, whatever it is. 204, as it happens, is a multiple of 4, right? It's 4 into 51q. So in this case, it's very, very straightforward. All I had to do was make this conversion. 204q is 4 into 51q. I don't care about this quotient. My 51q is equal to this p in this equation. So what I've done is I have taken this statement and brought it to this format. And then what remains therefore is the remainder, right? So your answer is r equal to 3. And again, before you finalize that this is the correct answer, remember the constraint, as it has to be lesser than 4. For example, if what you got here was a number like 7, that would not be the correct answer. Why? Because 7 again can be divided by 4 further. It's not the final remainder. If you have a number like 7, then what you should do is again try to identify the remainder when 7 is divided by 4. What is the remainder when 7 is divided by 4? You would again get 3 as an example. So everybody clear on this? Let's put it to a yes, no. It's a very, very important concept. The minute you brought it to this particular format, it's very easy to build it. And don't worry, if it's not clear, as we do a few more examples, you'll see what we're trying to do. How is it 4p? Because look at the question. N is being divided by 4. So 4 is the divisor. Let's come back to that note which we created if we have it, but otherwise it's okay. We saw that example, like 7 into 10 plus 5. That 7 is what is being divided by. All right, good. Now, and as we do a few more examples, this will be very clear. But the fact is, you already got the correct answer. That's r equal to 3. And 75% of the batch has got it. Now let's move on to the next question. Again, very, very interesting. And let me clear this. We're going to use the same poll. Remove broadcast results. Clear all answers. And the poll is open. All the best. Remember to apply the equation that we just learned. You can solve it in multiple ways, but the objective of this session is to solve it in a particular way. All right, most of you are done. Another 5 seconds. 3, 2, 1, and perfect. Let me end the poll. Let me broadcast results. All right. So some of you might have this question, hey, isn't this complicating something that you can arrive at in a very simple way? How many of you have that particular doubt? Hey, it looks a little, why go through all this pain of, putting it into an equation and solving it? You could just use that. You could even substitute numbers, right? You could try with number substitution and figure out. A lot of you will have this doubt. And To give you the answer to that question, it's very simple. At this level of question, it might be easier to do back solving, number substitution, all that. As the questions get tougher, that's when your process orientation really starts to matter. That's when, if you have this background of being able to put it in a format like this, it helps. So these questions you could do every which way, you would still be able to solve easily. But as the questions get tough, that's when you realize that you really need a strong fundamental framework. And that's where we are coming to. And we are building to that. So for those of you who felt that 8, 9, and 10 were difficult, right? Hold on. After the next few questions, when you come back to 8, 9, 10, try applying everything you learn here and let's see the difference. All right, that's good. Good points. So option A was the most popular option and option D was somehow chosen. Now let's look at how do we go about this. Very similar, right? What are we asked? What is the remainder when n is divided by 5? So we need to find the remainder when n equal to 5 p plus r. That p could be anything, I don't care. That could be, you can call it x or y, whatever it is. That's the quotient. But you need this remainder, and because you're dividing by 5, you know that the constraint is the remainder has to be lesser than 5. So that's what the question is asking us. Now look at what's given to us. A number when divided by 205 gives the remainder 6. N equal to 205q plus 6. Now, the reason so many of you chose option D is going to become very, very apparent. So here, if you observe this, yet again is the same exercise. I have something expressed this way. My job is to express it this way. If I express it this way, I'll get my answer. It's as simple as that. That's why I want to express it in this way. So 205q, how do I change it to some kind of 5p? In this case, again, very, very simple, right? Because 205 is a multiple of 5. 205 is simply 5 into 41. So 205q is nothing but some 5 into 41q. My 41q is basically the same as p here. So what would remain? So you have successfully expressed it as some 5q or some 5p plus 6. This is where a lot of students make a mistake, because they forget the constraint. R has to be lesser than 5. Because if it was 6, if it is greater than 5, then this would again get divided by 5, right? This would essentially be 5 into 1 plus 1, leaving the final remainder as 1. If you failed here, all of you who chose option D, you got it till here, but then you didn't notice that there is this constraint. If you're dividing something by 6, if you're dividing something by 5, 6 cannot be a remainder, because 6 again can be divided by 5. When you divide 6 by 5, you would get a final remainder of 1, and this would be the final answer, which is actually less than 5. Those of you who went wrong in this, some level of clarity coming through on why 1 is the correct answer and 6 is not the correct answer. It's very, very important. This constraint, if you're not focused on this, you will go wrong here. For the 4 of you who have not got it, what is it that's not clear? It should be clear at this point. Actually, you can put it on the Q&A. I think Ashutosh can help out with that. But fundamentally, think about it. Can it be 6? If you're dividing something by 5, can the final remainder be 6? No, because 6 is again divisible by 5. No, not divisible, but 6 again can be divided by 5 to arrive at a final remainder. It's not, this is not your final destination. It's just an in-between. How 41q equal to p? We honestly don't care what q and p are, J. The idea is that some quotient. My job is only to represent 205 into something as 5 into something. It really does not matter what that exact p is, what that q is. My job is how can I express that 205 into something as 5 into something. Here it's very easy because 205 is actually a multiple of 5. It just happens to be 5 into 41. So 41q, you can consider that as 5p, as p. It's as simple as that. All right, this is good. But with this, we are done with the warm-ups. So we are all up to speed. All of us are now aligned as far as the core concepts are concerned. Now we are gonna raise up the level a little bit. So I hope you guys are looking forward to that. Because the questions that we just covered are basic warm-up questions. You should be getting most of this right, as we can see right here. The core learning is you need 200% clarity in the concept. As far as quant is concerned, I told you, you need to know the core concept, but over that, there is a layer of logic. It's not just core concepts. But if you do not have clarity here, you cannot really answer the question well. So, clarity on the core concept is extremely important. The real GMAT questions that we're going to see now are much more advanced. It will be more like the first questions that you solved today. All right. So can we have a yes if everybody's looking forward, just ensuring that we are all on the same page? And let me hide this. Perfect. Now, before I get into that, let me also talk about personalized study plan. I see that some of you have pinged us about how to go about, preparing for GMAT in terms of what kind of planning should you do. So very simple, guys. As e-GMAT really helps out students in this regard. If you, let me just bring up the link. If you click on the link that's provided here, let me just bring that in. Yeah. For those of you who want some help with creating a study plan, because especially if you're targeting that 730 plus, some of you will definitely want a very, very crystallized, clear plan. We can help you with that. Why is this good? Because the plan that we create is customized to your ability and your time availability. So if you click on the link, it will take you to a page where you have to choose between specific problem areas. You can kind of figure out where your problem area is. Then you get on a call with our certified strategy experts. These are guys who have seen tons of success stories, thousands and thousands of students who have done well on the GMAT. We kind of know what it takes. So they sit down with you, you have a discussion, they'll make you take a Sigma X mock, which is the closest to the GMAT. You get a very good estimate of your starting ability, and not just at a very broad level like quant and verbal. It's broken down to a section level. At a very sectional level, how good are you in quant? How good are you in number properties? How good are you in critical reasoning? You get a extremely strong breakdown of your starting ability, and then we couple that with your time availability. When are you planning to take the test? How many hours can you spare on a weekday? How many hours can you spare on a Sunday? We take all of that into account and help you build a plan that's personalized to you. The milestones are based on your ability. If, for example, if you're already super strong in number properties, you should not be spending as much time on it as you should be spending on a weak area like geometry, right? The Sigma X test is exactly like the GMAT. It's a simulated GMAT test. Right now it's probably the closest that is there to the GMAT as such, if you ask us. So for all of you who believe that you can get some help with the plan, the links are there. Make sure you try it out. It could be very, very useful for you. Let's get into some 650 to 700 kind of questions. Before I get into this, let me bring back the option pod. From here on, it'll be GMAT style questions, so you'll see 5 options, by the way. All right, there we go. Hey, before that, let me get this out of the way. Let's begin, guys. Let's click on still solving. Let's get a few folks in. Make sure you participate. This is what I call a low risk environment. You participate, you get feedback, you know if you're faltering. If you're doing fantastically, that's also something you know. All right, so yeah, quite a few of you have chosen still solving. Let's go to the first question. All the best. Alright guys, most of you are done. 80% of the batch is done. So let's take another 10 seconds and then let's get into discussion. Four, three, two, one, and let me end the poll. Most of you are done. Let me broadcast the results. There you go. And let's get this out of the way. All right. So I have a question for all of you. All of you who participated and, answered this question. How many of you solved this using actual mathematical calculation? How many of you actually multiplied 30 and 8.2 and figured out what was m and, used that to calculate the remainder? How many of you did 30 into 8.2, multiplied and then got the correct answer? Yes, I did. LOL. Exactly, that LOL is a sentiment that I also have here. So you can do this for questions like this, but as the questions get more complicated, you'll find this very difficult. It's not a scalable way of solving a problem. Yes, that multiplying 30 into 8.2 and getting 246, you could do it for a question like this where the numbers are small. As the numbers get complicated, as more other logical constructs are added to the question, it becomes very difficult. So right now, 56% of the batch used what I would say is not the ideal method. You could get away with it for one or two questions, but not all the questions. You would do it, but then it will kill your time, and then you'll wonder about where your time went. Your time went because you wasted a lot of time doing this. So we talked about that equation. We should be using that equation. So what is the remainder when m is divided by 15? Or in other words, what am I concerned with? If I divide m by 15, some quotient that is p I don't care about, the remainder that is r, this r, as we've already discussed, it cannot be greater than 15. That's the constraint you always have to keep in mind. And let's look at what we are given. M is a positive integer, well and good. M by 30 equal to 8.2. So in this question, we gave it in a slightly more difficult format. All you had to do was, let's split this. It's all about trying to visualize this and putting it in a different format. If you look at 30 into 8.2, you can actually split this, right? 30 into 8 plus 30 into 0.2. If you have done this, after this, all you have to figure out is, hey, how do I convert something that looks like this into this format? I already have, and there's a clue right here. You already have 30 into 8. What is 30? 15 into 2, right? All you had to do was take the 2 out from the 30 and put it in the other bucket. Or in other words, I took the 2 out of the 30, used it to multiply with the 8. This number I don't care about. Whether it is 16 or 600, I don't care about. But the fact is, now I'm representing it as 15 into something plus, what does this translate to? 30 into 2 into 0.2? 6. What is the answer you guys got after all that calculation dividing 246 by 15? What is my answer? The answer is the same, right? And this again, I want you to develop the habit of using this method, because this method will scale. This method will work when you're doing the tougher questions as well. Everybody with me at this point? Let's hear a quick yes. Have you understood what we have done here? My job was to convert this into some 15p plus r. How do I do that? That's where my creativity comes in. That's where I think, all right, 30 is just 15 into 2. I just need to get a 2 out from 30. That's it. That's all it took. If this is clear, now let's go to the next question. We're slowly building to the next one. And we're going to use the same poll. So let me clear all results and reopen. All the best, guys. Next question on your screen. All right, 80% of the batch is done. I'm going to wait for another 10 seconds. Let's get your answers in. Three, two, one, and fantastic. I see a bit of last minute magic happening here in this question. All right. So I can see that you guys have started applying the concept. This time you were able to apply the equation. Did you follow the approach that we prescribed? How many of you used the equation rather than doing the calculation? Perfect. The bigger number is very inspiring because that's kind of what we want to see as well. And that also kind of explains how you guys did not struggle as much this time. So the accuracy has also improved somewhat, right? Very same approach. My question was, what is the remainder when m is divided by 30? How do I translate that? We already know. The constraint is r has to be less than 30. Always keep track of that. What was given to you? M is a positive integer. Well and good. M by 15 is 8.2. So we did the same exercise. Let's split this up. 15 into 8 plus 15 into 0.2. Now, this is where it gets interesting. The difference is this time I want to express this in terms of this. So you have 15, you need 30. What do you need? You just need to take a 2 from somewhere, right? And here in this case, luckily you already have a 2 readily available here. All you have to do is pull out a 2 from that 8. And the minute you pulled out a 2 from that 8, you're able to express this equation in terms of this framework. So you got 30 into 4 plus 15 into 0.2 was basically 3. And therefore and again you always have to check 3 is lesser than 30. Fine, we are perfectly fine, no issue. And so 3 is your correct answer. So 90% of the batch have got this. Very interesting question. If 2 is not available, then how to solve? I'm glad you asked that question. That is in fact the very next problem that you're going to see. You couldn't have asked it at a more opportune time. So the next question is precisely going to test you on that. So let me reopen the poll. You guys can start with still solving. So the answer to your question should come from this particular explanation once we solve this. Both Akash, and for your question as well. All right, 80% of the batch is done. Let's wait for another 10 seconds and then we'll get into this. All right, 3, 2, 1, and let me end this. There you go. Broadcast results. So 67% of you chose option E. Some of you chose option B. So I have a hypothesis about why you chose option B, but I also want to know from you what exactly was prompted you to choose option option B. So the answer to your questions is gonna come right here. What happens when you don't have that 2 available to pull out, right? You just have to get a little creative with it. So again, the question has the same template. What is the remainder when m is divided by 30? So you need m equal to 30p plus r. You need to find this r. Constraint to remember, r has to be less than 30. All right. So now m is a positive integer. M by 15, you're given it's 9.2. So m equal to 15 into 9.2. We follow the same approach. We broke it down 15 into 9 plus 15 into 0.2. And this is where you guys would have started thinking, how do I get 50? There is no 2 here, right? Earlier, either this portion had a 2 or this portion had a 2. So it was very easy to pull it out and make it in this format. What do I do in this case? The answer to that is also very simple. Just a little bit of creativity. How can you express 9 in terms of an even number? One example, and probably the easiest example would be 8 plus 1, right? Does this make sense? You could take any other even number also, but it's easier if you take something like 8 plus 1 because the multiplication with 1 is a little easier. It kind of becomes easier to calculate overall as the numbers get bigger. These are just simple examples, but fundamentally now all I did was split that 9 into 8 plus 1. We're just being creative here. And when you do that, now you got the 2 that you needed, right? To get the 30. 15 into 8 plus 15 into 1 plus 3. 50, and from this particular relation you got 30 into something, which is what you wanted. 30 into something. What that something is, I don't care. Plus whatever remains. So essentially I got 30 into 4 plus 18. Again, I have to check. Is 18 lesser than 30? Perfect. Then it's the correct answer. If this number was, let's say, 32, then your correct answer would have been the remainder when 32 is divided by 30, which would have been 2. That's the key point that you always have to remember. Yeah, a very good question that somebody asked. A couple of you are asking this. Can you use 2 into 4.5? The answer is no, you should not, because you have to remember that you're dealing with integers. These are all integers. You do not do the split and making it a decimal point. All right? It's because you're dealing with integers. Your divisor is meant to be an integer. If you split that 9 into 4.5, it's not an integer anymore. You can do 10 minus 1 also. Absolutely, Kush, you're correct. And we are actually going to get into that concept in the next couple of minutes, in the next 5 minutes. It's a very important concept that we're going to discuss. So I'm glad you brought that up. So let me do a quick check. Everybody feeling comfortable with this, what we are doing here? The logic is coming through? Perfect. It's very good to see those yeses, but participate. I need to see more yeses. I want to make sure that you guys are there. Otherwise, you can feel free to click this one as well. Because there are around 150, 160 odd people here, so make sure you guys participate. So for those of you not entirely sure about this, put it in the Q&A. We'll help you out. But you understand what we have done, right? We broke this up this way. And then we said, hey, we want it in this format. We want to represent m as 30 into something plus whatever the remainder is. How do you get from 15 from this to this? That's all you need to think about. Here, you did not have a 2 ready for converting 15 to 30. So you got a little more creative. You did 8 plus 1. Aditi, the reason you can't choose 4.5 is very simply because your divisor is an integer. All these numbers are integers. Dividend, divisor, quotient, remainder. They are all integers. Therefore, you cannot put in a fraction there. That would be incorrect. Alright, so just keep it in mind. Just don't go towards an integer. You do 8 plus 1, it's fine. You do 2 plus 7, it's fine. As long as there's an even number, it's fine. 8 plus 1 would be easier because the 1 is smaller. Easier to calculate. Alright, I'm happy to see that. So quick overview of what we have discussed. Now after this we are going to get into 700 plus level problem solving questions. You saw that we raised the difficulty. In one case, all we had to do was pull an 8. You had 30, you just have to take out a 2. Here you saw that you had 8, therefore you could take out a 2. This is the case where you needed to get a little more creative. 8 plus 1, 2 plus 7, but always take integers. It's as simple as that. Quotient can never be a fraction. Absolutely. They're all by definition integers. You need to keep that in mind. So what we've done is we progressively, you would see that the difficulty level is going up. And if you're careful and if you remember all these things, reminders is one of the easiest scoring avenues on the GMAT quant, if you ask me. So let's get into 700 level questions. Let me get this, clear this, broadcast, reopen. You guys can start, click on still solving. Let's get into the question. Before we get into the question, I think we have an important concept that needs to be covered here. I'm assuming that by this point, I've given you a glimpse of how powerful this equation is and why it's so important. Now, let's kind of build upon this. So we're getting into hardcore remainder theorem right now. We're talking about the additive and multiplicative property of remainders. All right. So if I asked you a question, what is the remainder when 31 plus 43 is divided by 7? There are two ways of going about it. You could add 31 plus 43, that would give you 74. And when you do 74 by 7, it's fairly obvious that the remainder is 4. Again, remember, I would put this as 7 into 10 plus 4. My remainder is 4. This is one way of going about it. Another way of going about it is, hey, why do I even have to add these two things? Can I not take the remainder at these points? Would it not be simpler? And the answer is this actually works. If you find the remainder for 31, for these individual terms, 31 when you divide by 7, what's the remainder? 43 when you divide by 7, what's the remainder? What is 31 by 7? 4 into 7 plus 3, right? What is 43 by 7? 6 into 7 plus 1. And if you add the 3, you notice that you get the same answer both ways. So what that means is, when you have multiple terms being added, the remainder can apply to each and every one of them individually. And sometimes it's easier to calculate it this way. You have to use your judgment, which is the quickest way to calculate this. So that's something that I want you to keep in mind. Sometimes it may be easier for you to just add this. You never know. But sometimes it might be easier to split it up. Now, if I went, instead of addition, if I changed the operation to multiplication, 31 into 43 divided by 7. Here, you could do this multiplication, but you know, it kind of gets a little complicated, right? To actually find the remainder for a complex number like this. This is the place where the beauty of remainders comes in. In such a case, if you used sequence 2, do you see how it's much easier? If I gave you these two options and held you at gunpoint and said, which one will you use? What would you choose? What would make your life easier? Make sure you understand this. Sequence 2, absolutely. Because again, the remainder is 3, the remainder is 1. And what you'll notice is, in both cases, you'll get the same remainder. So even when you have 31 into 43 divided by 7, don't get into this trap of thinking that, hey, 31 into 43 divided by 7 means, 7 only applies to the product. No, you can find the individual remainders in both cases and simply multiply them. It's as simple as that. And you'll see how this eases. For some of you may be familiar with remainder theorem and how this works, but any of you who are not, for whom this is new, if this is new to you, this is a game changer. This and the subsequent concept that we are going to discuss is a game changer. It will really simplify the way you solve remainder questions properly. So, if the multiple is greater than the divisor, then you again For example, let's say that when you multiply these two, you got a number like 12. Again, the same rule applies. 12 is greater than your divisor. That means you have to find, again, divide this by 7 and find the remainder. When you divide 12 by 7, what would be the remainder? 5. This would be your final answer. Same approach. If you find that that multiple, when you multiply these two terms, is greater, again, you have to find the final remainder. That's, again, very, very important. That's a good question. I'm happy you asked that. If this is clear, let me quickly explain the logic of this. For some of you may be wondering, hey, how is this happening? Why is this happening this way? It's very simple. If you do the math, you can actually kind of see that it will work. That's right here. Say if it was 31, you would express it as 7 into 4 plus 3. Likewise, 43 is 7 into 6 plus 1. If you just simply add this, what you see is exactly the same. And you can just bracket these and this together. 7 into 4 plus 6 plus 3 plus 1. So 7 into 4 plus 6 is some 7 into P or 7 into Q, we don't care, plus 4. But what is this 4 fundamentally? Simply the addition of these reminders, the individual reminders. So, or in other words, instead of doing 31 plus 43 and finding the final answer, you can simply find these individual reminders and sum it up. That's the logic for the additive nature of reminders. For the multiplicative side, it's exactly the same. Think about it. 31 into 43 is this into this. Expand this bracket, this is what you would get. Take out 7 and group all the 7 dependent things together. You would get 7 into something plus 3 into 1. And again, you notice that the final remainder is this 3 into 1. This multiplied 3 into 1. It's as simple as that. So this is kind of the theoretical explanation of why this works. Perfect. So now let's look at the next question. Again, the objective is you should apply what you just learned. Alright, so most of you are done. Another 3 seconds and then we're going to discuss this. Alright, so now let's discuss this. Let me broadcast the results, and 64% of you chose 0, which is the correct answer. Option A is the correct answer. 30% of you fell for this trap option choice, that is C. And tell me one thing. Just because you learnt something new, you don't have to forget your logic. Why is 0 the correct answer here? Your 24 is divisible by 3, right? It's completely divisible by 3. 24 is 8 into 3. Which means any multiplied product of 24, whatever it is, whatever this monstrosity is, it's going to be divisible by 3, right? Because 24 itself is divisible by 3. How many of you just saw this and immediately chose the correct answer? That is 0. How many of you put that, tried to, express it in the formula, etc., etc.? Because some of you would have tried all that and broken your head and eventually chose 2. So they see me, ha ha ha. Exactly. This is just a reminder that, reminder that also keep your logical hat. Don't forget to keep it simple. You're given that 24, you know that 24 is a multiple of 3. The answer should be within 5 seconds you can answer this question. Correct? Also, don't forget the basics. That's another thing. But even if you, those of you who chose option 2, the mistake you would have made is you probably mixed up the operator. So you would have figured out the 24 bar 3, it boils down to 0. And then you would have taken plus 36 plus 2, you would have arrived at 2. And then you would have thought, okay, you see the 2 here, and that's probably why the answer is 2. This is not 700 level. Actually, yeah, this is 700 level. This is 700 level problem solving. You're right. But it's not DS. It's still not as complicated as 8, 9, 10, if you ask me. But exactly. But this is a question that you can solve in 5 seconds. It's as simple as that. So that's just a reminder. Don't forget your logic, core logic. Let's look at the next question, guys. Let me clear all answers, broadcast results, reopen the poll. There you go. All the best. All right, most of you are done. I'll give you another 5 seconds for it. 3, 2, 1, and let's pause. So, most of you have got the correct answer. It is 2, by the way. Option C is the correct answer. Some of you fell for option choices like B and even A. Let's go through this particular question. The concept is pretty much the same, but there's the difference is here I'm also introducing power into the equation. So there's some learning as far as power also. That's a good question, Ravish. I'm coming to that. The short answer is, surprisingly, power does not really play as much of a role in remainder. So fundamentally, if you take 25 into 38 power 3, it's nothing but 25 into 38 into 25 into 38 into 25 into 38. We already saw the multiplicative property, right? When you have A into B into C, or what would you do typically? You took it individually, right? For each of these things, you calculated the remainder and then you multiplied it. Now you look at this A. A is also some X into Y, right? Again, what would you do? Look at it individually. So the fundamental question is, despite this existence of his power, what it comes down to is 25. What is 25 when divided by 3? What is the remainder? And when 38 is divided by 3, what is the remainder? It's almost like that 3, that denominator 3 is kind of going into the bracket. Do you see? That's what we kind of try to represent here. Do you see what's happening? It's purely because of that multiplicative effect. So the power actually does not matter, surprisingly. Because what is power? Power is just multiplication, right? End of the day. And we have already seen that when it's multiplication, you can take it individually. It does not matter. Power has an impact. I'll tell you where it has an impact. We are getting into the concept of negative reminders. That's where you'll really see an impact. It has an impact on your final answer. So in this question, for example, all you had to do was, what is 25 by 3? What is the remainder? It's 24 plus 1. So it's 1, right? And 38 by 3, 38 is 36 plus 2. So 1 into 2. So essentially you got 2 power 3. Power matters only at this point. In this simplification step, 1 into 2 power does not matter. After that it matters. Because what is 2 power 3? 8. 8 is greater than 3. Remember your constraint, remainder cannot be greater than 3. 8 is greater than 3. So what do? Divide 8 by 3 and find the remainder. What is that? 2. Is this concept coming through? It's very simple, right? Once you've figured it out. As far as simplifying 25 into 38 power 3 and getting that remainder components like 1 and 2 is concerned, the power absolutely does not matter. After which you probably have to do into 3. That's about it. Make sense? Positive sign where? It's the same. Whether it's even the same logic applies for plus and multiplication, right? That's what we saw in the previous slide. The concept was still the same. It does not matter, and that's what you'll see. Good question. But is some clarity coming through? Is some learning coming through? This is actually a breakthrough, right? Such a simple way of solving this. I don't care how big the number is. It's 25 into 38 power 3. Perfect. What is 25? What's the remainder? 1. 38, what's the remainder? 2. What is 1 into 2? 2. And then you have the power. Then finally I have to think about power. 2 cube is 8. 8 is greater than 3, whereas your remainder should be lesser than 3. So what do? Find the final remainder. 8 divided by 3, your final remainder is 2. Just the correct answer. And remember, 80% of the batch is getting this. It's simple. It's simple. Once you get the hang of it, this simplifies everything in remainder for you. After this, remainder questions are not the same, if you ask me. So I'm seeing some comments. Yes, really helpful. Good. And again, we're going to build upon this. So keep that in mind. The core learning here is everything we saw. Additive property. You could just take each and every component separately and find the remainder. Multiplicative property, could just take out individually and find the remainder. Even with power, if you have 31 cube divided by 7, eventually it's just 31 by 7. It's like that 7 has gone into that bucket. All you have to find is what is the remainder when 31 is divided by 7, and then worry about the cube. It's as simple as that. If you're able to apply this, all those questions are going to get much simpler. Now we are getting into the next important concept. Pay a lot of attention to this. If you liked what you just saw, especially for those of you who are not familiar with remainder theorem, if you liked what you just saw, what you're going to see now is going to be even more interesting. It's what is called as negative reminders. In simple words, imagine that you are dividing 5 by 2. So this is one way to express it, right? 5 is nothing but 2 into 2 plus 1. There is another way of expressing this. Then that would be 5 is also 6 minus 1, right? So it's also 2 into 3 minus 1. This is what we call as a negative remainder, this minus 1. Instead of your typical remainder is always positive. In reality, your remainder is always positive. Negative remainder is a concept that we use to simplify. This is more like work in process. This can never be the final answer. Anytime in any option choice on the GMAT on a remainder question, if your final answer is negative for what is a remainder question, there's probably something wrong there, right? Because notice negative remainder is like work in process. It's not the finished good. The final finished good is you have to convert it back to positive, and we're going to look at that. So another example, say you're dividing 8 by 3. You could write this as 6 plus 2. That's what I've done here, positive remainder. Or you could say 9 minus 1. So 3 into 3 minus 1. Why is this interesting is this kind of, in a lot of cases, it's much easier to calculate if you're using negative reminders than when you're using positive reminders. And we'll see examples of that as well. Now the question is, I told you that negative remainder is purely work in process. It's never the final answer. So the question you should ask is, how do you convert a negative remainder to a positive remainder? The answer is right here. Let me also explain the logic behind that. All right. Think about the example that we took. 5 can be expressed as 6 minus 1. That is 2 into 3 minus 1. Let's add and subtract the divisor. The divisor is 2. So I'm going to add 2 and subtract 2. And then let's kind of rearrange everything that's here. So take this 2 to this side. You'll get something like 2 into 3 minus 1. and then minus 1 plus 2, which gives 2 star 2 plus 1. What you have observed is what started as a negative remainder, by adding and subtracting the divisor, you're able to arrive at the positive remainder. Now, the positive remainder is what portion? So if you are given a negative remainder like minus 1, how do you get the positive remainder? This part in yellow. Your negative remainder was minus 1. Your divisor is 2. How do you get positive remainder? Minus 1 plus 2. That's that part in yellow. So always remember this. If your negative remainder is minus 1, if your divisor is 6, then you should do minus 1 plus 6 to get the final remainder, that is 5. Keep that in mind, never forget it from now on, because now things are going to get interesting. Let's go to the next question. I'm going to reopen this poll. You have solve it any way you want, but try to apply what you just read. All right, most of you are done. Another 10 seconds. Three, two, one, and wonderful. By the way, I'm very happy looking at the results because I see a lot of good responses. And those of you who are already strong with it, you guys are solving it within seconds. But there are a lot of you who are taking that time, applying that process, and choosing the correct answer. So that I also see that gradual increase in that correct answer happening. So that for me is people learning now. So option D is the most popular option. 80% of you have chosen this. You should not have chosen option A simply because I told you reminders should be positive. Now, you can solve this question both using the positive style and using the negative style. All right. If you simply start simplifying this, what do you get? Split it right here to start with. 24 into 38 by 5, 38 divided by 3 plus 17. You have to find that remainder. Now, if you look at this portion, you remember that question where we saw that, hey, 24 is already divisible by 3. Therefore, whatever it is, this monstrosity should be divisible by 3. Same logic, which means the remainder of this portion is 0. Everybody with me so far? And if you pressed A by mistake, happens. That's why you have to keep in mind all these things. So that leaves you with 17 by 7 divided by 3. What is the remainder? It's as simple as that. How do you calculate that? You could do 15 plus 2, but then you have to deal with plus 2 power 7. Then 2 power 7 is 128, and then you could do that. You would still get the correct answer. Otherwise, you could do 17 is basically 18 minus 1, negative remainder. And then it becomes very simple. If it's 18 minus 1, all you have to worry about is minus 1 power 7. And what is minus 1 power 7? What is minus 1 power 7? It's simple, right? Minus 1 power 7 is minus 1. Because minus 1 is a negative remainder, you don't just rush and choose option A. You add back the divisor. So minus 1 plus 3, that is 2, is the final answer. It's as simple as that. You could do it with this as well. Only difference is then you would have to deal with 2 power 7. I believe that's 128. And then you would try to figure out something like that. That's a lot more complicated. It would be much easier if you just did this. So This is the power of negative reminders. And this is still a fairly easy expression comparatively. Some of the expressions that you see have much larger digits. It goes into much more complex territory. When you see questions like that, use your judgment, jump into negative reminders, right? That's very, very important. Next question for you. Again, be very, very careful with solving the question. All the best, guys. Somebody had asked a question about factorial. With factorial, it's also a product, right, at the end of the day. So the same rules of product apply as far as factorial are concerned. Poll closed. Thanks a lot for telling me. Let me open it up. There you go. Thanks a lot. All right, most of you are done. Let's take another 3 seconds out there. 3, 2, 1. And let's pause this. So yeah, these are 700 level questions. Now they look a little easier. I'm happy to see that. Thanks for the feedback there. That's good. So option E is chosen by almost 90% of you. It's very, very interesting. It's good to see that because we know it's the correct answer. I know it's the correct answer. I'm seeing that progressively, even though the questions are getting slightly more difficult, the accuracy is increasing. So that for me seems to me that you guys are getting this. So I'm very happy to see that. So very similar. I have this expression. First, let me use the additive nature. I can break this down. I can separate this. So 24 power 3 into 38 power 5 divided by 6 the remainder plus 17 power 7 divided by 6 the remainder. That's what I'm concerned with. Same logic, 24 is directly divisible by 6. Therefore, this portion is 0. I need to worry about 17, the remainder when 17 power 7 is divided by 6. Again, you could use this or you could use this. This might be easier. So 6 into 3 minus 1. So minus 1 to the power of 7 divided by 6 is all I'm concerned with. Or in other words, minus 1. Negative remainder is not possible. Therefore, I need to add 6. So my final answer is 5, which is the correct answer. If you have got this, there's nothing like it. Simran, you'll have the PDF anyway. It was in the theoretical explanation of how to arrive at that. The fundamental point you need to remember is if you have a negative remainder, let's say you got minus 1 here, all you need to do is add the divisor. The divisor was 6, so add 6, you get the final answer. I hope that should help you out. So you guys are getting it. So the core concept here is negative remainders. It is work in process. You cannot use it as your final answer typically, but it can really help you simplify the calculations, and that's what you're seeing here. And positive remainder is negative remainder plus divisor. Keep that in mind. With this, we're actually back where we started. You're going to solve the same questions that we solved then, and then we're going to see how we're going to perform. So who's ready to take a crack at the first three questions, the ones that the data sufficiency questions that we did. Perfect. Now let's have fun. If I can see improvement, that means that there's something there. Oh, I see a just bring it. I really love that, man. Reminds me of wrestling as well. All right, so let's get into. You can use the same poll. Because we're gonna continue the discussion with this. You can use the same poll. Let's attack question number 8, round 2. There you go. All the best. All right, guys, most of you are done. Let's take another 5 seconds. Let's finish this up. 3, 2, 1, and let me end this. And now what I'm going to do is, let me broadcast the results. So choice A is the most popular. Let me contrast this with how you guys performed the last time. So you guys can see the results, right? So for the same question, by the way, option A is the correct answer. So 63% of you have got it right this time. This was 40% in the last go. In fact, this was not even the most popular option the last time round. 43% option C was the most popular option. But something you guys have done really well. 63% of you have got it. And for the remaining 27% of you who are kind of fixated with option C, don't worry, we're going to explain that as well. So you did worse. Don't worry, man. You still have 2 questions. So that's there. So it's good. It's very encouraging to see this. You can see the improvement, which means that something in this session has resonated with you, has come through to you. Some of those strategies have worked, whether it is negative remainders or core remainder theorem. Once you understand it, it's very, very, very easy. These questions are actually much easier once you get a hang of it. All right. So let's get into discussing the data sufficiency questions. So again, what is the remainder when a positive integer p is divided by a positive integer m? You're given that m is greater than 1. Simple. The question is fairly easy. You have to divide p by m. Now there is no other data here to analyze. There's nothing here which I can do. So let me go directly into statement 1. What does statement 1 say? P equal to n plus 1 per 8. Alright, so let's do that. So P equal to n plus 1 per 8. So all I need to do is find the remainder of n plus 1 power 8 divided by m. And we kind of already saw this, right? It all comes down to 1 power 8 divided by m. So, or in other words, your remainder is 1. In other words, you're able to find a specific answer using statement 1. Statement 1 is sufficient. And that's why options B, C, and D can be eliminated right there. Everybody with me so far on why statement A is correct? Statement A is sufficient to answer the question. If everything we've discussed is there, you can see. Or even take an example. Let's assume that m equal to 10. So 10 plus 1 power 8 by 10. What is the remainder? It's going to be 1, right? If you just needed a quick bit of validation from a non-algebraic root, you can do that as well. But just purely from the variable, you could be able to figure it out. Let's look at statement 2. The problem with statement 2, and this is where I think some of you might have considered statement 1 and 2 together by accident. It tells you that m equal to 8, but you don't know anything about p. You're looking at an equation like p divided by 8, find the remainder, but you still don't know what is p. If you don't know what is p, how can you find the correct answer with the statement alone? For the people who chose option C, a little bit of clarity coming through, which is why you cannot identify the solution. You cannot solve this just by statement 2 alone, which eliminates option D as well, which is why statement A is the correct answer. It's very, very, very simple. So I saw the comment. Some of you solved this within 20 seconds this time. Very, very happy to see that, because it can be solved. Shall we move on to the next question? These are the 700 level questions you started with. Shall we move on to the next question? Question 9. Perfect. Let's hear a few more yeses there. How many of you here? Yeah, 130 of you here. Oh, all right. Perfect. So it's very, very simple. Very, very simple. Data sufficiency. So you have to be careful. When you're evaluating statement 2 independently, don't add the information from statement 1. Why is statement 2 useless? Because you know that m equal to 8, but that would still leave you with find the remainder of p divided by 8. What? You don't know anything about p. And without information about p, you cannot solve this. So option A is the correct answer. So let's go to question 9. And I'm gonna edit this out. Clear answer, remove broadcast, reopen the poll. Now it's time to do Kush, to answer your question, I think you need to kind of look at, let me just bring that data. So I think there was a note for that, DS answer choices. Just one sec, guys. Let's answer this question. Data sufficiency, you have to be very careful with what the options say. Option A says statement 1 alone is sufficient. Option B, statement 2 alone is sufficient. D says each statement alone is sufficient. Both statements together are sufficient does not make any sense when you can evaluate with option A. Anyway, let's get into question number 9. I think all of you are waiting for this. Let's get into it. All right, many of you are done. Let's take another 10 odd seconds. All right, last 3 seconds. 3, 2, 1, and take a final shot. There you go. Let me end the poll. All right, so I have my test on Thursday. All the best. All the best. Do well. I hope this session and some of the things that we're discussing here is useful for you, man. I could not crack S2. I understand that. Let's don't worry about it. But trust me, you all the concepts, either from a maths perspective or from a logic perspective, everything is right here. All you need to learn is a little bit of how to go about and follow a very systematic logical approach, which is what we're trying to imbibe here. So let me just broadcast the results. Option A was chosen by 42%. And again, let's do that compare and contrast, which I keep telling you about. Let me check. Are the results visible? Yes, they are. Option A is the correct answer for this question. Last time 28% of the batch chose this. Now it's increased by 42%, which is good. So quite a few of you have converted somewhere, are using better processes, I suppose. So from 28% to 42%, that's the improvement. Some of you fell for option D, and we'll discuss that as well. So let's get into the discussion of how you guys did this particular question this time. Again, it's not very difficult once you understand it. If n is a positive integer, what is the remainder when 38 power n square is divided by 13? So simple. 38 power n square is divided by 13. Yeah, it's written here. 38 power n square is divided by 13. We need to find the remainder. Given that n is greater than 0, it's a positive integer. What else do we need to do? Here, on the other hand, before jumping into these statements, how many of you spent some time analyzing the given question before getting into statements 1 and 2? How many of you spent some time on that? If you spend some time just analyzing this before getting into statement 1 and 2, there's a good chance that you did most of the question right. There's only one other trick point where you could have faltered, which would probably lead you to choose option D. So yeah, I understand. I also know where you went wrong. I'll come to that. So if you simplified 38 per n square, again, we know that it's all about getting to that actual remainder. 38 negative remainder, this is easier, right? It's either positive remainder, that is 26 plus 12, that can give you 38, but I'm not going to bother with 12 to the power of something. The easier way is 39 minus 1. So can you guys see that this boils down to minus 1 power n square? Eventually it's minus 1 power n square. When it's divided by 13, what is the remainder? So what it really comes down to is this minus 1, and more specifically n square. Because minus 1 to the power of an odd number is minus 1. Minus 1 to the power of an even number is plus 1. So what actually happens is you need to figure out whether n is odd or n is even. If n is odd, n square is also odd. That means minus 1 power n square will give you minus 1. If n is even, that means n square is even, and minus 1 to the power of even will give you a remainder of plus 1. We do not consider 12 only because it's a pain to calculate 12 power anything. We don't even know what n is. On the other hand, with minus 1, it's so easy, right? It all comes down to odd versus even. It's very simple. If n is, if a number is odd, its square is odd. If a number is even, its square is even, right? If n is odd, that means n square is odd. If n is even, that means n square is even. And what matters is n square. If n square is odd, that means minus 1 to the power of some odd number. You will get minus 1. It is a negative remainder, so you have to do minus 1 plus 13. Your final answer will be 12. And if it goes the other way, minus 1 to the power of something even will give you a remainder of plus 1. Everybody with me at this point? So what it actually comes down to is simple odd even. What you need to figure out is, based on statements 1 and 2, is n odd or is n even? That's all you need to figure out. If you get the answer to that question, you have solved this question. That's as simple as that. So let's look at statement 1, now that we have understood this much. First statement says n leaves no remainder when divided by 4. Or in other words, n is divisible by 4. And anything that's divisible by 4 has to be an even number, because it's 4 you're dealing with, right? Which means, as per statement 1, you can infer that n is even. And because n is even, you have a definite solution to this question. Answer can be found. So statement 1 is sufficient as it stands, which is why B, C and E are rejected straight away. You got confused with positive and negative value. Just be a little careful, take a little bit of time, you'll get this even in your exam. All it takes is a bit of care. Let's look at statement 2. This is where some of you, especially those of you who came this far, a lot of you definitely came this far but then got lost. You would have got lost because you did not consider all cases, and I'll tell you why. You're given that root n is only divisible by 1 in itself. Quick question for you. When is any number divisible only by 1 in itself? What does that tell you about that number? If I tell you that, hey, there is this number x which is divisible only by 1 in itself, absolutely, I like that answer. It means that this particular number, that is root n, is a prime number. If root n is a prime number, it could be 2, 3, 5, 7, it could be any of those. What would be n? Root n square, right? If root n is a prime number, it could be 2 or 3 or 5 or 7 or whatever. So what would n be? 2 square, 3 square, 5 square, 7 square. We don't know what the number is. But here is the problem. Because of the existence of this one thing, that is 2 and 2 square, that's where your answer changes. Every other prime number is odd. Almost correct. But the problem is you still have 2. 2 is considered a prime number, and therefore 2 square. N is 2 square. This n can be even still. Or in other words, you're not able to resolve this odd even conflict. It could still be even. And those of you who missed out, you might have missed out because you failed to think about 2. Did that happen to anybody? Because usually it does. Usually one set of students have this problem. Absolutely. Exactly. So here is the key learning for you. This is what we call as consider all cases. This is where the GMAT tricks you. You know the mathematical concept here. This is what I told you, right? It's a basic level of mathematical concept, but there is this outer layer of logic that is very important. This point is not mathematical concept per se, it's more logic. You have to think, hey, there is this case that I have to remember about that as well. Cyclicity of B. I understand. Perfect. So I think you put that on the Q&A. It seems a little complex, so we'll put it on the Q&A. Ashutosh can help you out. I'll move on. I think we should. It's 45. I want to cover the next question as well for you guys. But essentially, because it does not resolve this odd even conflict, you don't know whether it is odd or even from statement 2, which is why option D gets eliminated. Only statement A is sufficient. It's as simple as that. That is precisely the use case. N is, you say n can be 4, right? If n is 4, this is even, no. But n can also be odd. What if root n is 3, then n is actually 9. So it could be this or it could be this. It could be odd or it could be even. The use case which you are providing, n can be 4. That is precisely the reason why I don't know whether n is odd or even, whether n square is odd or even. Very, very, very interesting point. And this is, you will see tricks like this everywhere on the GMAT. But if you stick to the process, if you remember to be a little careful, you will not fall for this. Let's come to the last question. Let's do an attempt and let's wrap up this session. Clear all answers, broadcast. Let's have some fun. Poll is open. Thanks a lot. Right, 80% of the class is done. We'll wait for another 10-15 seconds and then let's wrap this up. All right, guys, last 3 seconds. 3, 2, 1. And let me end this. Good job. Let me broadcast the results and let's bring our comparison. How did we do the last time versus how did we do this time? So what is the correct answer, guys? What do you think is the correct answer? I like that confidence. So D is the correct answer. All of you would have probably evaluated statement A, was the first statement, but statement D gets a little deep into logic, and that's where some of you may have faltered. But look at the improvement. From 45 we moved to 52. That's good. Some of you fell for option A because I think you might have got stuck with option D, statement 2. You might have got stuck with the second statement, m cube is divisible by 16. So yes, this was the toughest question here in today's set, and especially evaluating that statement 2 is a little difficult. That's kind of where there's a good chance that some of you have faltered. But good, I'm happy to see, again, I can see the improvement here. I hope some of you at least feel that way as well, because if that's done, I think at some level we have done a good job. So let's get right to analyzing this one. Question is clear. What is a remainder when 4m is divided by 6? I don't know what m is. All I know is it's greater than 1. It's a positive integer greater than 1. So I'm concerned with what happens when 4m is divided by 16. What is the remainder? Simple. So far, So good. We don't have any other data, so now we need to get into statement 1. M leaves a remainder of 4 when divided by 32 per 32. Let's talk about what we have. So let's come back to our core equation that can help here. 4m, so if you divide 4m divided in by 16, what, there is some quotient, there is some remainder. We are interested in this particular remainder. What are the constraints as far as this remainder is concerned? As always, it cannot be greater than 16. It has to be lesser than 16. That's why you've seen lesser than equal to 15. It can be 15, but it has to be lesser than 16. That's the constraint, and it has to be greater than equal to 0. Rather, this one. Always remember, don't forget the constraints. What else do we know? That's about it. We need to find the remainder. Let's look at statement 1. Statement 1 says m leaves a remainder of 4 when divided by 32 power 32. So our equation says we can translate that into math. It would look like this, right? Again, we are following the same process, by the way. I want it in this format. What I have is this format. What do? Somehow I want to get it here, right? Firstly, here I want 4m. So what do? I multiply by 4. As simple as that. I have m equal to 32 per 32k plus 4. How do I get it to that format? Simple. Multiply by 4 first. So 4m equal to 4 into this particular thing. What does that lead? And the beauty of 32 per 32 is you can actually split it, right? You can take out a 32 to get it into this format. Eventually you want 16 format. 32 gives you everything you need. All kinds of 2s are available right there. So all I did was take out a 32 and then 4 into 32 into 32 per 31 into k plus, because I multiplied by 4, you have 4 into 4. Did you guys all do this when you're doing your analysis? Make sure that you're doing this. If you have done this, things get very, very straightforward. So I have everything I need here to represent this particular portion as a function of 16, something 16k. So it is some 16 something plus even this term comes to 16, right? 4 into 4. So fundamentally your 4m can be expressed as some multiple of 16. And if that is true, your remainder when you divide by 16 is 0. You're getting a concrete answer here. So option A, statement A as it stands is more than enough to solve your question. That's the first piece. You could do that also, but I think this would be an easier way to go, frankly. That's why we are focusing on that. But try it out, M by 4, try it out and see what happens. Let's look at statement 2. That's where things get a little interesting. And pay close attention, because I'm sure this is where some of you at least fell. You're given that m cube, m to the power of 3 is divisible by 16. M to the power of 3 is not the same as m. It does not tell you anything about m. So let's think about m. If something is divisible by 16, what can you tell me about it in terms of, let's say, odd or even? If something is divisible by 16, can you say that it is odd? Will it be an odd number? Ever? Is that possible? No, right? By definition, if something is divisible by 16, it's even. That's my starting point. So I know that if m cube is divisible by 16, that means m is an even number. That's kind of what we started here. So that means m is equal to some 2 power something. For example, if your m is 40, I should probably pick a better example. Like it should be divisible by 16, right? So if you look at an example like 48, for example, m cube or whatever it is, it would be some 2 power something something something. The fundamental is m cube is divisible by 16, which means m is an even number. An even number can be represented this way. There is this 2 power and whatever other prime factors are there. This could be 3, this could be 5, that could be 7, 13, whatever it is. But there is this 2 power a. Everybody with me so far? The next step is more interesting. What are we interested in? M cube, right? We need to find out about m cube. So what do I do to this m? I cubed it, which tells me that m cube contains something called 2 power 3a. This is there, this is definitely there in m cube. Correct? Let's hear a quick yes or no. Are you guys with me? Following the logic here. I started with m cube is divisible by 16. Therefore, m is an even number. Therefore, m is definitely some 2 power a into something. Then I'm concerned with m cube. Therefore, I cubed it. So m cube is some 2 power 3a. That's it. As simple as that. And what do you know about m cube? You're given as per statement 2 that it's divisible by 16. But what exactly is 16? As one of you pointed out, 16 is nothing but 2 power 4. So this 2 power 3a at the very least has to contain the number 4. It could be more, it could be 12, it could be 24, it could be much greater than 4, but it has to be that multiple of 4. So at the very least this 3a has to be greater than equal to 4, which means remember that all these numbers are integers. A greater than equal to 4 by 3. The bare minimum value of a is 2. If you got this, then you would have solved the question correctly. Why? If you got a, the minimum value of a is 2. What happens if you put it here? Your m is 2 square into something, 2 power 2, because the minimum value is 2. M is nothing but 2 power 2 into something. I don't care what that 16 is. So m, I already know that m is equal to 4 into something. And in this question, are we concerned with m or are we concerned with 4m? We're concerned with 4m, right? From m cube I got m, from m I got m cube. Now from this m I need 4m. I'm multiplying by 4. So at the very least you have 4 into 4 happening. It's 4 into 4 into something. I don't care what the something is. But 4m equal to 16 times something, which means remainder is yet again 0. Very interesting, right? This particular option, the logic is a little more deep. And that's why this is the toughest question that we had for you today. That's the reason why it's here. But do you guys see the logic? 3a has to be greater than equal to 4, not 2. Why? What is given to you? M cube is divisible by 16, right? And what is m cube? 2 power 3a into something. This has to be divisible by 16, but 16 itself is 2 power 4. So your 2 power 3a at the very least has to be equal to 2 power 4. Otherwise you cannot have 16. It's as simple as that. Think about it. Spend a little bit of time. For those of you still not getting it, spend a little bit of time on this. You'll get it. And then you'll be like, oh, this is fantastic. So some of you can feel it already. The logic here is a little deep. Because of that, there is the bare minimum value of a is 2. It could be more. It could be 6 or 8 or it could be something much, much higher. But at the very least you have 2. And the minute you have even 2 here, 4m becomes a function of 16. 4m becomes a multiple of 16. Which means option D is the correct answer. Even statement 2 is sufficient. It's kind of great, right? So this was the toughest question we had for you because of that statement. Go through the logic for some of you who might still be a little bit hazy about this. So this is a monster question, I agree. Core takeaways for all of you. GMAT quant, it's not at all difficult. I mean, it's not easy as well, but it's not as difficult as some people think it is. You can get that Q50, Q51. As I said, it's not about math per se. Definitely you need to have that basic understanding of math, but there is this layer of logic that is very, very important. And that is essentially looking at the scenarios. Like, hey, there could be this 2, or there could be this other situation where it's not odd even. There are all those subtle things that you need to figure out, and that's logic. Anybody can improve from a low con score. And trust me on this, we mean anybody. Look at example number 1. We have a few case studies for you, for those of you who really want to see, who really want to see the words of people who have been there and done that. Krish scored a Q51, that magical Q51, he scored that. Look at what he has to say. This is a guy who is topping his math classes since childhood. This is a guy who is really, really good at math. Typical template of an Indian engineer, that stereotype that exists. But when he started with GMAT quant, there was a struggle. Not because he does not know the concept. Of course, he knows the concept, right? It's about how do you making following a systematic framework to solve the questions. Everybody can learn the basic quantitative stuff. Everybody can learn remainder theorem. All of you guys learned remainder theorem, but still only 52% of you got the correct answer. The remaining is the thinking that you have to apply. He talks about how we keep the variables till the end without substituting. You can read a lot of this. Do go to GMAT Club, check out reviews for e-GMAT. You'll see a lot of positive word about the quant course, especially in recent months. We've kind of totally revamped the quant course. So those of you who have been through the quant course know what I'm talking about. So this is one use case. Initially, the problem was he falls for those traps. What is an example of that trap? In that odd even question, if you did not pay attention to that prime number 2, that's a trap. Everything else you did correctly, but you fell for that trap. So that's something you need to look at. Leonardo is another example. This is a dude who was stuck at Q45. Try as he might, he was not able to get through. What helped? The process, a very, very methodical approach to solve the questions. That helped him. He was also able to utilize Scholaranium at a very, very good level. He was able to pinpoint everything. And of course, he was able to leverage the practice questions in Scholaranium. This guy got admitted to Stern, Tepper, and even Wharton. Mazibar, for those of you who feel that, hey, let's talk, I'm not yet at that level, let's talk about a smaller level. Mazibar is an example of somebody who was at a 20th percentile. He got only a Q30, but a structured approach to learning got him to Q45. May not be your Q51, but there, you still see an improvement. So this is a guy from a commerce background who's not really comfortable with the quant questions. So what he liked about the course is how it starts at the very low level questions, the easy questions to build that base, which is, by the way, what we have done today. You thought about those 5 warm-up questions. Most of you got it right. Those are low level questions intended to build your fundamentals. So Mazibar is an example of somebody who benefited from that aspect of our course greatly. Guillermo is another example, somebody who had a significant improvement from Q38 to Q50, and eventually he ended up getting an admit from Wharton. And it's all about that process, guys. End of the day. To ace GMAT quant, focus on learning, build these habits. What do I mean by these habits? Think about this, all this process frameworks and all. Every time I kept asking you, remember this constraint, it has to be lesser than 5. That's a habit to ensure that I do not forget. Make sure you build those concepts. Ensure that you cannot do the logic part unless you have clarity on the concept. So first build 100% clarity on the concept, then follow the process step by step. Oh, this is a line that's very, very important. Believe in the test maker. Everything that is being put on that test is solvable, including this last question. Once you've gone through the logic a couple of times, you'd be like, hey, this is actually not that difficult. Next time you see a similar question, you'll be able to crack it in no time. Believe in yourself, trust the test maker. Quant is not going to be that difficult. So with that, we kind of come to the end of things. What you should do further, for those of you who are e-GMAT students, you already have access to all this. For those of you who are not e-GMAT students, check out the free trial. We do have all these concept files that are free, that's available for you. I'm sure it will help you at some level. The PDF that we are going to share right now, this also has some practice questions that is designed for you. Make sure you do that as well. So that's it from my side. We are done. Let me give you the session handout as well. Just one sec. Yeah, here you go. And if you guys have any other general feedback, we'd be happy to take those as well, and any other general questions that we'll be able to handle. Otherwise, you can also write to the support team. We'll always help you out. Let me also bring in the quant process skills link. So I talked about all these process skills, right? So here you can check those out. And for those of you who believe that what you saw today was useful and you want to explore further about building a study plan, that link can help. Get in touch, see if it works out for you. All right. Thanks for the feedback there. Yeah, Harshvardhan. Okay, you have the same name as me. The recording will be shared with you. It will reach you on email, and it also usually gets uploaded to YouTube. So you'll find it. And thanks, Ashutosh. I think you've had a lot of questions that you were answering to. Thus, thanks a lot for supporting. Good. All right then. So with this, let me stop recording.